So same carbonyl compounds and reaction with ammonia, it will form loss of water molecule and it will form imine compounds. And so reaction with NH3, even aldehydes can form imines. And ketones reaction with in presence of dilute HCl or C double bond NH. And so just to remove that this H2O and it will form imine. And very interesting example is that it is a biologically very important. So the reaction between 6 moles of formaldehyde and ammonia, so urotropine, so very two cyclic ring component from this is called urotropine. And you can see here some of the good example. Benzaldehyde reaction with aniline in presence of dilute HCl also it can form. So skiff based compound, this is called a skiff based compound imine, so IMINE. So then so even dicyclohexanone ring reaction with methylamine, and this is the imine compound. And even cyclopentylamine reaction with it is from imine ring. And you can see very nice different examples here. And cyclohexanone reaction with primary amines and even secondary amines under acidic conditions it will form a enamine. So enamine is very important reagent to form a direct CC bond formation. For example, cyclohexanone reaction with pyrrolidine in presence of acidic medium, it will form a like this compound. And so that it can is a very, what is the mechanism also you can see here, and how this enamine can form. And so that this enamine is because of, so very good example. So we can see that. And an addition of hydroxylamine, aldehydes ketones reaction with hydroxylamine in acidic medium, it form oxime, this is called oxime. And so that it can form a different oximes and very good key intermediate products for the Beckmann rearrangement reaction. You can see that here in this example. So different examples are given here, and please be noted. And very interesting examples here. You can see that IUPAC nomenclature of carbonyl compound. So for example 1 2 3 4 5 6 is there. And so how we can give the numbering of this one? So 1 2 3 4 5 6, so this is 1. So 3 at third position it is carbonyl is there, and so that this is 3 hexanone. And another example you can see here 1 2 3, so 4 5 6 7 8 like that will be there. And so that this is called 6 ethyl and 4 4 dimethyl and nonane. So 2, so yeah, 3 nonone. This is the example. And you can see that different carbonyl compounds here without so no alpha hydrogens here. And here 4 alpha hydrogens is there, here 4 alpha hydrogens are there. And very important, how to prepare this aldehyde. You can see that this is the primary alcohol in presence of PCC reagent in dichloromethane or Swern oxidation DMSO, and carbonyl chloride in triethylamine base, it can convert into the aldehyde. So and ozonolysis also important method. Generally there are different methods are there, and among that ozone in presence of dimethyl sulfide also ozonolysis is possible. And hydrogenation and oxidation, hydroboration reaction also it will follow the anti-Markovnikov product, and it so by using of hydroboration oxidation method, terminal alkynes gives the aldehydes. And whereas this alkynes, terminal alkynes in presence of H2SO4 and mercuric sulfate as a catalyst, and it will give the ketones, and it will follow Markovnikov product. And even acylation reactions also produced that so that acylation of Friedel-Crafts acylation reaction. So very nicely you can see that the hexanol is there, and primary, this is secondary alcohol is converted into ketone by using of sodium chromate H2SO4 condition, and primary alcohol converted into aldehyde by using PCC reagent. And here even alkyne, right, BH3 as a catalyst, and hydrogen peroxide oxidation and hydrolysis, it gives the aldehydes. And even ozonolysis in presence of DMS and you just add one oxygen here and oxygen here, and so terminal alkyne gives the ketone. And you can see that, so in exams such they will give that, so which reagent is the in Friedel-Crafts acylation is involved. So benzene converted into so isobutyl group. So you just disconnected here and benzene and reaction with the so isobutyl chloride. So this is about the some of the important mechanism. So you can please note out the how the mechanism is involved, the nucleophilic addition reactions. And there are a different, you can see that very good examples here. And for example, this is the dialcohol is there, and it alcohol also internally it can act as a, in acidic condition it can act as a nucleophile, so that finally water molecule eliminated and a bicyclic, that spiro compound can be formed. And you can see this is the protection by using of ethylene glycol in presence of acidic condition. And you can see the different so variety of in base condition it will form a carbon ion. And so you can see that here ketone is there and ester is there. So ester only can be selectively reduced, so we need to protection of this carbonyl group, so by protection of this one and T protection, so that. And you can see that here also in place of acidic medium, and this cyclization will involve and it will form like this. And so that finally so we'll get this product, and even elimination also taking place as cyclic ring. And please noted at different products here, benzaldehyde reaction with the methylamine and even ethylamine reaction. So this is the mechanism of that overall process. Thank you.